Today we are going to be talking about the particle model of matter. So, the particle model of matter is a scientific theory that we use to explain all matter, solids, liquids, and gases are made of particles. Right? So we are explaining the model of matter. Model is, for example, you build a model of a spaceship, all right? You're going to create a way smaller representation of that spaceship. The same thing that we do with atoms, right? We cannot, look at an atom with a naked eye. So we describe the atom and we build the atom with, materials that we can find on Earth. The particle model of matter also states that particles, first of all, are atoms or molecules, and they are so small and you cannot see them with the naked eye. An example of a molecule is water, right? So particles are atoms and molecules in a nutshell. Point number 2. We also know that the atom can be described as the smallest particle of matter that can exist by itself. It can exist on its own, right? And for example, the atom of copper, right? Copper atoms can exist one by one on their own. Atoms don't usually exist on their own, though. Most atoms are attracted to other atoms, like magnets attracting to one another. The force that keeps them together is called the force of attraction. The forces of attraction between atoms pull them together to make molecules. So we have two hydrogen atoms that bond with one oxygen atom to give you the molecule of water. And the bonds or the glue that sticks all the atoms together is called the force of attraction. Matter is everything around you. Particles are the building blocks of matter. And what did we say particles were? They are atoms and molecules. So matter is everything around us, from the solid bed that we lie on every night to the liquid we drink every day in the form of water or teas or juices, to gases, the gas that we breathe in, oxygen, or the gas that we breathe out, carbon dioxide, right? Or even the gas that is formed when we boil or evaporate water. So matter can be found in 3 states: solid, liquids, and gases. And lastly, all particles, remember that particles are atoms and molecules, have spaces between them. Some spaces are larger than others. Spaces between the particles are completely empty, right? So this is an amazing concept because everything you see around you is filled with particles, filled with atoms. Even the air that you breathe but you can't see is made out of millions and trillions of atoms and molecules. But between each of these atoms, if I have to zoom in a little bit here, we see that there are spaces. Even the most tightly packed atoms will have spaces between them. And those spaces are basically empty. There's nada, nothing there. Okay, a brief recap of matter. So matter is made out of particles called molecules, and if we break molecules down, we get atoms. So atoms make molecules, and molecules make up matter. Let's look at a droplet of water. So if we have a droplet of water over here, we know it's the smallest part of water that we can see, right, with the naked eye. But this drop is made out of billions and trillions of water molecules. But obviously we cannot see these water molecules. Each water molecule is made out of even smaller particles called atoms. So the next part we're going to be talking about are solid, liquids, and gases. First of all, the arrangement of the particles in a solid, right? Remember, Particles are atoms and molecules. However, particles arranged in a solid, they are packed closely to one another, right? So we see that there are not many spaces between the particles of a solid. Next thing is the movement of particles. How do particles behave? Particles do not move freely, but did you know that each and every thing on Earth, every particle of matter moves in some way? And in solids, they vibrate against one another, all right, as in this diagram. The next thing is the force of attraction. Solids have extremely strong forces of attraction that hold them together. Next thing, spaces. So solids have the smallest spaces between them. As we have discussed before, there is, a very tiny space for particles between one another. And then we come to shape. So if we have to put just say a cube of sugar, just like we have in the diagram, into a test tube, all right, it's not going to change, the shape is not going to change to accommodate the shape of the container. The shape of a solid is going to stay as a block of sugar, right? And solids keep their shape because particles cannot move, right? If the particles could move, the solids would, form and mold in the shape of the container. And lastly, compressibility. Solids cannot be compressed because spaces between them are too small. When we want to compress something, we want to push the particles together so that we can add more particles to the solid, but that cannot happen in a solid particle. Let's look at an example of a video. So for example, we had to test compressibility by adding chalk to a syringe, all right? And let's see what happens when we try to press the syringe against the chalk. Can it compress? And how much can we add? So can you see how he's pressing against? And it just doesn't happen, right? It just doesn't compress to an ideal state, right? There's just so much that we can compress a solid. We couldn't compress the solid because there is extremely small spaces between the particles. There's no space for the particles to go. As simple as that. All right, so the next state of matter are liquids. The particle arrangement of liquids is that particles are loosely arranged but are still quite close to one another. Can you see in this picture? It's not like a solid where there's a fixed pattern, but there's no fixed pattern in the liquid, right? They all are, freely moving, but not so far away from one another. If we look at the movement of the particles move around quickly and they bounce off one another and slide across one another. And this means that they have more energy than solid particles, right? So the forces of attraction between particles of a liquid are weaker than that of particles of a solid, all right? Because there's not such a strong force keeping the particles together, therefore they can bounce off one another and slide past each other. They have the ability to move. Spaces, obviously they have bigger spaces than between their particles than that of a solid, but not as big that where they can just get lost like a gas. The shape. So the awesome thing about liquids is that it takes the shape of the container that it is in, right? They don't have a shape because the particles move freely and bump against one another and the sides of the container. They take the shape of the container holding them, as you can see in this picture. And lastly, compressibility. How well can we compress particles in a liquid? And I'm going to take you to a video so you can. Okay, let's see. Can you see he's trying to compress it? and it stops at a certain point because there's no longer spaces left for the liquid to pass through. Wow, look at that. The last state of matter we will be discussing today is gases. So the particle arrangement of gases is that they are widely spaced and they have no particular arrangement or fixed pattern. They move rapidly, they move in all directions. They don't have a strict direction, right? Movement of particles, they move very fast and freely and they bounce off one another and other things. So they have a lot of energy, right? And movement energy is called kinetic energy. The forces of attraction, what keeps them, the particles together? Not much force, right? So they have extremely weak forces of attraction between them. It's very difficult for them to get lost compared to liquids and solids. Spaces, they have large spaces between them, as we can see in this diagram. Shape, gases take on the shape of the entire container. So if we had to drop some gas into this beaker over here, it's going to encompass all the entire beaker itself. All right, so they fill the space that contains them because the particles are moving in all directions and they naturally spread out. Think about if you spray some perfume at one end of your room. In a few minutes, you'll be able to smell the perfume on the other side of the room because the particles have dispersed. And lastly, compressibility. They can be compressed as particles will fit into the large spaces. Because there's so large spaces, particles can be pushed into those spaces, and then more and more gas can be added until you cannot add any gas. And that reminds me of when you're filling a tire with gas, right? Your bicycle tire, you will compress it by adding gas, and then at a certain point when there's no spaces left, then you know that your tire is full. I'm going to take you to a video to put this into visual. Okay, so now we have a gas, and can you see he is pushing the syringe with his. Can you see how much he can compress it? Right, way more than he would a liquid and a solid. Okay, your homework for today is you need to answer number 1, 2, 3, and 4 and complete the table. All right, you don't need to write in detail. Just give me a strong point for each characteristic of a solid, liquid, and a gas. I hope you enjoyed this video. Bye.